Thank you so much. I'll start by saying I'm honored that you've decided to spend the next 30 to 50 minutes with me. I'm not going to be rushing, so I'm going to be walking through my presentation on a peaceful manner. I'll see if you start nodding, then I'll speed up. So half of my presentation is going to be basics, and the other half is going to be talking about actual AI. So be patient, you as well. I'm going to be live coding some, but we'll get back to that afterwards, or let's dash later. I'll start by saying that lots of the movement has been started naturally by GitHub. I'm not going to be bound into GitHub, but it's as they are the most advanced currently in this technology, it's the most natural place for me to present the technologies in AI-driven development. As a starter, which those of you who were early, you've already seen as a starter, to give you some sort of a thinking base, one of these pictures is real. It's actually taken exactly 18 months ago here in Copenhagen, near Revshaløyen. Sorry for not pronouncing it correctly. And 3 of the others are descriptions of this one real picture to DALL-E, which is essentially very close to the same as what we're doing with AI-driven development. Some of my slides also have a QR code, so if you're bored or interested, you can just scan it and read for some more information on the topic. The latest research that has actually been made on the topic is naturally by GitHub, and even if you have to take it with a pinch of salt, what they state is developers are going to be 55% faster by using AI co-piloting, whether the technology is Copilot or then say GitLab Duo or similar. And I'm just going to quickly present what this means. So I have a small application made in JavaScript, currently showing a line. And then I have a file called week number. And this example came from, I was working with my son who is doing university studies. And he had a Python course and he had to do all of the exercises. And next to him, I was working with Copilot to do the same exercises. And it took me less than a minute to solve the exercises that had been put in place. And for this particular presentation, I'm going to use a similar programmer's dilemma, which is called date calculation. So let's do a function gets week number, gets a date as a parameter, like so. And then let's open the function, and you'll see that all of the algorithms that I have to come up with, the AI Copilot already gives me. So with a few tabs, and then exporting that function, like so, and clicking save, I should see the week number. Done. So that was easy. Have a great day. No, just kidding. But you already see that doing the actual maths and the algorithm and all of that in very, very basic situations, the AI co-piloting does make us lots faster. With a friend of mine, we even took it a bit further. We created an OpenAI-based pull request reviewer using only OpenAI. Meaning that we asked all of the code from essentially ChatGPT for the code to create a pull request reviewer. And you can now find it in the marketplace with the name AI Code Review Action. I'll quickly show you how it looks. It's here. So there is an old pull request called changed color to blue. And if we read down, we can see that GitHub Actions has already made some comments in there. You can see, oh, consider adding JS doc, saying that's not necessary to create a copy. So the kind of review comments that you would as a human being also give to the pull requests. But now, of course, with the addition of of the help from AI. Good. Now as we're there, and we at Eficode have been working with lots of, how should I say, more traditional organizations. We worked with GE Healthcare in building their newest patient monitor. And when we started the project, we already knew that it's going to take us 3 to 5 years to create that patient monitor, put it into the market, and get all of the certifications done for it. And when we talk about like quick coding the algorithms, and then on the other side, we have the 3 to 5 years development time, we already know that there is an issue somewhere. This is from another customer. We made a value stream mapping. And the value stream mapping, all of the yellow post-it notes here are manual steps to get one requirement through the organization, through the value stream, through the pipeline into production. And you can already see that the actual development value happens between 2 post-it notes. And now if we start improving something between these 2 post-it notes, we already know that no matter how much we improve this part, we will not make the organization faster. We will not get anything out faster. And if traditional organizations spend 5 to 10% of their actual R&D time and budget on software development, and we improve that by 55%, we've improved the organization 2.5 to 5%, which essentially is not good outcome from what we have at hand. And here we get to the basics. So when we start doing AI-driven development, when we get our organization faster, and as I said, I'll start from the very basics. There are 6 areas I want to introduce before jumping into the actual AI-driven development. The first one, naturally agile practices. I trust everybody here already knows roughly what that means from roughly 22 years ago with the Agile Manifesto and organizations trying to become more agile. And so here's Atlassian Jira. Tool that I love and hate at the same time. Almost all organizations use it today. It's great for reporting, it's great for managers, it's great for someone who wants to overlook things. And if we think of the modern software development, how that would work is, let me pick the change colors to blue. We'll make a new branch. It was 16, yes. Colors blue, like so. So now we have a new branch with the tag name colors blue, and we push it to a version control system, like so. We've created a new branch, change colors to blue, and by not touching the actual requirements management tool, which has said for us developers is really boring, we've been able to mark a point in history where something actually happened, which means that for the organizational agility with automation, we've been able to create something that happens just in the background without the nuisance for developers or the R&D organization. Of course, you decide how to solve this kind of agility in your organization, but any requirements management tool today supports the way where developers are blocked as little as possible. The next part, CI/CD, another very basic practice that all of you are already familiar with. But with the introduction of the continuous integration, continuous deployments, organizations have been able to add a layer of continuous practices in the organization. And if we look at the YAML file, so here's just simply the CD YAML file, the most boring possible example of CI/CD pipeline in use. All it does, it checks out the code, it runs the the build, the test, and then some linting. And this is where it usually starts for organizations, and then it goes further and further. And if we go ahead and check out the actions, we can see the process that has been run here. There it is, CI, test, and run lint. Fantastic. Now we have the CI/CD in place, and it's guardrails for our actual application development. And then we get into more interesting part, the continuous quality assurance. So we've now established agility in the organization. We have the requirements going through the organization. We're trying to make way for organizations to be able to move according to needs and customers. We've established a continuous way of checking the quality of what we've created, and now it's time to look at the test automation. And of course, how this works is that we have tests, and we run the tests with the code we just created. Okay, 4 tests, and all of them have passed. And as you know, the tests these days are written in such a format that they actually define the requirements. So we have the original requirements, and the definition is written into the tests, whether they're unit tests or acceptance tests. And they work then as a framework to make sure that what we created is working, and then when we're creating something new, that's also working. And now, chronologically, cloud native was invented then next in line of all of these basic practices, but something that makes, for me, the cloud native today most interesting is that not only do you develop the code on your own laptop, but if we take the styles, let's make this steel blue, save there, and color azure, pun intended. There we go, and we make a commit. Let's add both. And we push it. And we go check out what's happening here. We have the colors blue here. And instead of now having a staging environment and a production environment and 2 environments that are then one that we use for testing and the customer testing maybe even, and the production environment, we actually are able to deploy all of the different branches. So here's colors blue, and if we go and check out this particular deployment, I'm using a service called Vercel. We click here, we can already see that it has been deployed. Week number hopefully works, Vercel app. And we can actually, if you wanted, you could even collaborate on this particular version. The original version naturally is running in week that hopefully works, and it's still in its production version of the boring gray color. So today when we start thinking about cloud native environments, it doesn't mean anymore that we have the traditional practices in place, but we can start imagining and looking outside the box, meaning that all of the deployments, when you run CI/CD, just to give an example, you can deploy everything and start using especially those web-based applications to be run in a service that's taking care of the so-called ops for you. Of course, this is not feasible for everybody, but especially when you are prototyping or building applications, rapidly deploying applications, this is super interesting option. And of course, Vercel is just one example. You could use Fly.io, or you could use Heroku, or you could actually, many organizations have built this one themselves as well. One of the key areas where when you're creating new applications, you can get them up and running and see how they are working. Then building the harness, 2 more pieces. One that I definitely want to mention, something that we have also in this particular conference present. The previous session in the neighboring cinema was really good on the security side, and there's lots of security tooling that's already available for you. This is an example stolen from a friend of mine, Stephanie Chaplin from GitLab, and she's kind of made a quite good list of tools that you can put in place already today and just start using automatically as part of your CI/CD pipeline. And if we look at how it looks in the tooling of example here, when we have the application up and running without actually doing anything, we can see the security issues that we have in this current application. So we've made the commit, we've made the pull request, and then we have the warnings here. And then, of course, if there is, let's say these warnings are coming from a library vulnerabilities, which is usually the most common problem, we get also automatically pull requests that we can just go and check out. So here's one. We see that in this case, Vercel has already deployed it for us. We can go and see the preview if we wanted. And then we see that all of the checks for this particular version have been passing, so CI/CD, and if needed, we could even merge it. And then the 6th one, my favorite, continuing from the agility. So a few years, actually just before COVID, Mr. Pies and Skelton, who had originally created the DevOps Topologies, wrote the great book Topologies, which I think is already familiar to all of you. But just as a recap, if we look at the original Conway's law, as you saw from the value stream, the organizations tend to create applications that reflect their organizational structure. And the team topologies has a target of changing that into a direction where the applications you create follow a more healthy architecture. And what they did, they wrote about 4 different typologies for teams. The most important, of course, are the stream-aligned teams that deploy applications. So their responsibility is to own a particular part of the customer value. Let's say it's a web application in this case. Then they would have a platform team or platform teams who are responsible for providing a certain platform, whether it's their own, say, backend platform, or then, for example, tooling platform. So the tools I'm showing here could be one of the platforms. Then there is the complicated subsystem team. So especially if we look at automotive or other very controlled organizations which has complicated parts of the customer product, there would be a complicated subsystem team taking care of that particular area. So a platform team for a vehicle could be, for example, the operating system of the vehicle, and then complicated subsystem team could be, for example, the sensors, which are usually demands very specific skills. And then the 4th one, of course, is enabling team. So all of the 6 areas, for example, which I've presented here, you would have an enabling team going into the stream-aligned teams, sometimes even to the platform teams, and coach them, give them assistance on how to put new practices in place. So even while I'm saying you all know about CI/CD, it's surprising how many organizations don't know about CI/CD as of today. Or even if they did, they would probably use it in a suboptimal way. Good. Now that we've set the scene for the basics, we're ready to jump into the actual AI side. So before showing any new slides, let's take a look at what we've created. So we have the week number here. Fantastic. AI created it for us. We have the tests running. Let's see, npm test. Still tests passing. We have, yes, our super nice blue application here. And then let's make a pull request for that. Let's see if it's there still. Yes. Feed update colors to blue. Let's do it. Create pull request. So essentially the checks have been already run in the background. We merge it. Fantastic. I'll just delete the branch because the commits are there. And then if we're any lucky, we'll go to Vercel. We check out the week number deployments. Still building. Should be ready in 14-15 seconds. And if we now go to the week.hopefully works, it should be blue. Yes. No applause, because I've added in a feature where you can set a date. And coincidentally, this year, the year starts from Sunday, which means that if we look at the date for the upcoming Sunday, which is 8th of October, and Sunday here in Europe is still week 40. But unfortunately, the algorithm I've gotten from the Copilot is saying that Sunday is week 41. So seems like we've failed something. Let's take a look at what happened. An easiest way, naturally, in a case like this is to write a test case. It should return week 40 for 8th of October. There we go. Let's see if it gives us any code. Looks good. Closing that one. And then let's run the tests. And oh no! For Sunday, for the test case that we've written for quite naturally Sunday, which was supposed to be week 40, our algorithm gives week 41. Let's see what happens if we try to recreate it. Oh, looks bad. This is essentially the same algorithm. So maybe we will just go to ChatGPT, which I've already generated for us, just in case it would be slow, or giving some other result, by the way. I'm going to copy paste it. The key term here was ISO format. And let's take it here, close it, module exports. Oops, too fast for myself. There. And then let's see, still week 40, all good. Let's test on the local host. Oh yes, looks good, looks good. Let's run the test cases. Yes, 5 of 5 passed. We can actually, we'll be just boring and fix the algorithm. Oh no, actually we cannot be boring because I just realized that I already merged it. So we're gonna have to open a new branch. Almost. There we go. And now if we go back to the week calendar, there should be fix calc. I know, didn't go to Atlassian. Fix algorithm, create pull request, and then we'll just quickly check once Vercel has done the deployment that it's not completely broken. Vercel deployment completed. Fantastic, looks good. Then we'll just merge it, confirm the merge. There we go. delete the branch. And here we had the weak number, and without just clicking frantically the reload button, I'll just let the build finish before reloading, just so I won't be too stressed. There. Now we're done. Oh, there we go. Thank you. Okay, so on to the topic. So now you had an actual demonstration how the so-called harness works around AI-driven development. So we had a quite difficult algorithm in place. I still don't quite understand all of the finesse of that algorithm. No, just kidding, of course. But it's not easy to understand, to be honest. And we've created tests also using AI-driven development. I'm just quickly going to mention that different from the model-based development, since AI does the generation independently for the code and tests, it's quite okay to do both as long as you understand what you are doing. And with CI/CD and all of the no ops, just deploying it somewhere and hoping it works, which it does because it's service they provide, we've now deployed a nicer, actually working version of our application. So where is AI good at? We've already seen that for the software development, it's going to make a huge change. But then there are 4 other areas for software development, essentially the UI UX, where so Adobe Sensei, for example, is a really good example of not only being able to bring AI into the graphical design, but also putting it in place for knowing what the customer or how customers or users behave in the site. Then DevOps practices, naturally, as some of you surely write Terraform still, Copilot will also help there. All of the AI-driven co-piloting will be helping there. And then a bit less on the agile culture and product and portfolio management, although it depends, of course, how organizational you are, how bureaucratical you are as of today, because, of course, ChatGPT will help you create very, very nice reports. In addition to all of these, we've already seen a movement called prompt engineering. What that means is during that last year we've had ChatGPT, have learned to do the questions, to have the prompts in a correct way for ChatGPT or other AI-driven engines. And it's a skill that has emerged out of nowhere. It's a skill that you have to have if you want to survive in the future of software development or digital age altogether. And there is already some tutorials, some help available for prompt engineering, but it's essentially a skill that we all have emerged, but is all from over. So something that's evolving, something that all of us have to learn. And for today, where we are standing today, there are 4 areas that AI-driven development is especially good. So as you already saw, naturally auto-completion of code tests and comments. So AI is pretty good at grasping the context you're working in and proposing you completions. So you actually have your idea of something you want to accomplish, and then you use AI to just fill it in, so to speak. The second one, which is one of my favorites, because when you start working on a new library, open source API maybe, AI has all of the knowledge. Of course, we know that their current cutting point is somewhere January 2022, but most of the libraries that we use today already has quite extensive documentation up to that point. So when we make questions to the engine, we get way better answers than usually looking at the API documentation. The third one, boilerplate code generation, which essentially means when you start working on a new project, you can get the boilerplate, the basics of that project from an AI. It has been done so many times that you can usually get even a better version than you would have done yourself, even if you had done it many times, because it's a condensed brains of all of those people who have been working on similar technologies already. And then something I'm using it for quite a bit is of course the new languages, new libraries. You can just go ahead and ask, how do I do sound analysis on Python, which I don't know much about, and it gives you good proper answers. Usually you can just build it simplified step by step. And then the most important part of my presentation probably is this particular slide. When we are here today working with the AI-driven development, and I showed you that it's quite easy to use, there are 4 key areas that I want to talk to you about, of which, of course, the first one is, as mentioned, prompt engineering, but all of the things I did there already require skills and they require training. So in organizations that are just jumping into using AI have to somehow solve, how do we upskill our people? How do we make sure that they understand all of the things that are needed in this organization regarding AI-driven development? How do we teach them the essential prompt engineering skills? The second one, so there is currently a class action suit against GitHub and Microsoft, which you probably know. It's unsettled, but it's running on its own track. And we know that Microsoft has added to the GitHub Copilot license that they will be supporting all of the legal actions against developers or developing organizations who have been using Copilot. But still, you have to be sure that whatever the AI-driven development assistant gives you, you have the right to use. And actually today, when you write code using Copilot or ChatGPT, since it's created by AI, there is no natural ownership of that code. So in order to place a copyright, you have to somehow change the code a bit. Judging by the sound, the after lunch wasn't the best time to talk about IPR and legality. But it's quite okay. It's going to be on the sound as well. But yeah, continuing from there, it's really important to understand the copyright reasons and how organizations are going to be using Copilot in their development to make sure that they're not accidentally using third-party code and that they are placing the proper copyrights on the code they've created using AI. And then third, of course, regarding the development team skills and training, it's important to make sure that in your organizations you have both the licensing correctly in place. So if you just go ahead and use the open source AI development tools, everything that you feed in, so everything that you feed in ChatGPT is going to be used in training the data in the future. So if you put in, say, API keys or some other secure information or even your own IPR code into tools like that, it's gonna leak. So you have to make sure that you have either the tooling in place in such a way that the data is, so the data remains as yours, or that you have guided your developers or yourselves to make sure that you're not leaking secure or important information into engines like this. And then, of course, as you saw already from my demo, the testing and validation is one of the key things. How to make sure, how to understand what you're actually working on, and how to verify that it works as it should. Going back to the DORA metrics, already familiar with you, but I'll show it always as my last slide to remind the organizations that had you AI in place today or not, the 4 key metrics that you want to measure in your organization to make sure that the improvement you do in different places of the organization actually improve the full value chain or the full pipeline of the organization. And of course, these metrics are lead time for changes, How long does it take for you to get the changes live? How fast do you recover from any issues that you have in production? How often do you fail in production? And then, of course, last, how often do you deploy? And the latest research, I think, on the topic says that 75% of the organizations already are able to deploy multiple times per week. So if you deploy once per day, you should be fine and on par. Super. Thank you so much.